If you self-host applications on your network, chances are you have a lot of IP addresses assigned to the services where those applications reside, and those things might be virtual machines or they might be containers or whatever. So welcome back to the Scotti-BYTE channel, and this is Scott. Today we're going to talk about backing up your home lab network. So in July of 2024, I presented a tutorial that was entitled Home Lab Network Monitoring, where we installed and configured NetAlertX. And I really like NetAlertX because it's capable of detecting and discovering all of the computers or all of the instances, IP addresses on your network, and then it allows you to track anything new that gets attached to your network as well. So many of you may also use Uptime Kuma to track the status of your known services, and this is great, but you have to configure it by hand. Anytime you add a new service, you have to go out and add a definition to Uptime Kuma, and then Uptime Kuma will track those services. But I often advocate the use of a DHCP server as a mechanism for centralized address management, and that's as opposed to setting everything as a static address on your main network. And that being said, I actually had 2 subscribers recently contact me and ask me questions about statically addressing everything because, believe it or not, in the case of one of them, they did not run a DHCP server at all. And a DHCP server brings an awful lot to the table, but centralized address management is one of those critical things. So DHCP address reservations are a way to allocate a fixed address that a system will get whenever its MAC address is detected on the network. And we do that all the time on the channel when we create containers in Incus or LexD. They, of course, get DHCP addresses, and we go off to the router and we say reserve that address so that anytime you see the MAC address of this container come up, go ahead and give it that same IP address. So what if your router crashes? Well, actually, if your router crashes or you purchase a new router, you're going to lose all of your DHCP address assignments. And the reason for that is because then the DHCP address database will be on your router if your router is the thing running DHCP, which is the most common use case scenario. So this is a major network failure if you can't identify your client or server instances when you bring a new router online. So I buy this new router, I set it up, and I go, wow, okay, my main network was 192.168.1. something with a 24-bit subnet mask. I set that up, and I even remember that my DHCP scope started at something like 192.168.1.50 and went over to 192.168.1.200. And you say, wow, everything's great. It's just like the old router. Well, the problem with that is, of course, it doesn't have those address assignments. And when those clients reach out, when their DHCP leases expire and they reach out to the new router and the new DHCP, they will get a new address. So if you watch this channel, in addition to physical computers, you have Incus, LexD, perhaps Docker, and virtual machine instances that all have a presence on your network, and they're probably all configured to get these DHCP addresses. So virtual MAC addresses are assigned to Incus, LexD, and virtual machine instances. And they're virtual MAC addresses because there's no hardware vendor associated with them, and so therefore they get a generated address. And on a new router, you may have no easy way to identify your many physical and virtual MAC addresses on your network. So what are the impacts to this happening? Well, many virtual containers rely on fixed addresses, as we mentioned earlier, in order to work. Nginx Proxy Manager that you use to host your public services for reverse proxy rely on these fixed addresses. And the address of Nginx Proxy Manager itself is probably a container, and it must be defined in a port forward on your router. And so, of course, you'll need to recreate that. But that address has probably changed again because the Nginx Proxy Manager instance itself got a new DHCP address. So if you use Pi-hole and its local DNS, all of your A records are going to be mapped to expected addresses. And so Pi-hole is set as a DNS in your router DHCP settings in order for it to work. And I like how Pi-hole's set up. Of course, you won't have any of these problems if you implement local DNS on your router where your DHCP server is. But my recent videos show why you might want to think of a few alternatives to that. So let's see how to make changing routers easier. You can see from my Heimdall screen here that I have quite a few self-hosted applications that are indicated. And if I go over to my GUI interface for Lex Console, which manages both my Incus servers and my LexD servers, if I simply go to VMS Mist, you'll notice that it has 35 containers. And then if we go in and look at those containers, we'll notice that there are quite a few entries. And as mentioned earlier, for example, NPM, Nginx Proxy Manager, has its own address, and on my network it is 172.16.1.215. But that's in virtue of the fact that it has the hardware address of 0016-3E-C5-921C, and that is a virtual MAC address. And that virtual MAC address will remain the same if I change routers, but will not remain the same is the association between that address and this 172.16.1.215 address, because that is a DHCP address reservation. And those DHCP address reservations apply to all of my Incus containers, my LexD containers, my Incus virtual machines, my LexD virtual machines, and even some of my Docker instances. Next, we head over to Uptime Kuma. And so Uptime Kuma is a great mechanism that can be used to alert you anytime one of your services is down. And you can see here that I have 74 services on my network, and that's only because I have defined 74 services inside of Uptime Kuma. So Uptime Kuma watches for those 74 services and reports on their status should they go down. And next, we head over to NetAlert X, and you can see here that I have 183 devices that at one time or another have been detected and configured on my network. Presently, 156 of them are connected, and I have defined 10 favorites. There are no new devices, and this is a real key feature of NetAlert X, in that anytime a new device comes on my network, it will automatically detect and report on it. So now I've opened a terminal prompt down here on my local machine, and I'm doing an Incus launch images :ubuntu/2404 on a container called test, and that container is going to be bridged to the main LAN. So when we do that and create that new container, of course, in a minute, we'll be able to do an Incus list and see that it has an address on the main LAN. And after just about a minute here, we'll do an Incus list, and the new container's gotten an address of 172.16.1.227, which is an address on my main LAN. In a minute or two after that, you'll notice that NetAlert X in the background is now logging one new device, and my number of overall devices has also increased. So if I click on new devices and I click on this name not found, it will bring up that container running at 172.16.1.227, and it is highlighted it as a new device. And if I uncheck new device and go off and save it, it will then be listed in my regular devices. But I'm not going to do that because this is a test device. I'm just going to go ahead and go out and delete it. So I go here and do a delete. I have another NetAlert X page up to the settings. And so there are some scanners that they have called the ARP scanner and the Internet Check scanner, and then a number of other scanners like NS Lookup and this AVI HI scan that are all in Folus that are all doing name discovery. And then of course I have my publisher here that I discussed in the video about AppRise publisher, which the AppRise publisher is another container that handles all of my alerts that get sent out to my Godify. Anyway, as we look down through this list, we're going to find that I, of course, have my various networks that I want to scan and watch for new devices. But the other thing that I want to point out is if we go over to the maintenance area and we go to backup and restore, I can do a CSV export of what I've got out here. And it will go ahead and create a backup file, and that backup file is a CSV. And so I can go ahead and import that into a spreadsheet. And here you can see that I imported that backup file into LibreOffice Calc. And so in the first column here, I have listed all of my MAC addresses, and then I've given each of these devices names that as they've been discovered in NetAlert X, I've entered a name for them so I can keep track of what they are. And then most importantly, as we move to the right in the spreadsheet, I will have also the IP address, or last IP is what they call it, of all of these things. So this would be a very good thing to have in order to be able to align the MAC addresses and your container names. Of course, the MAC addresses and container names aren't going to change, but the thing that's going to change is the DHCP assignment. So when you install a new router or perhaps reconfigure your old router, you would be able to go in and cross-reference this spreadsheet and then assign DHCP address reservations using these IP addresses in the spreadsheet in order to be able to restore everything the way it was with your old router. As a reminder, it's really important that these IP addresses align to the containers for which they're meant to represent. And part of the reason for that is because in your Nginx Proxy Manager, you're going to have all sorts of entries that point to IP addresses for your reverse proxied services. And we don't want those to change, and that's where that spreadsheet can also come in. So today was really all about trying to get a reasonable process to back up your home network and to allow you to restore it in the event that you were going to upgrade or change to a new router. So in summary, watch my Home Lab network monitoring tutorial to learn how to install and configure NetAlert X and your network event monitoring notifications. NetAlert X will alert you anytime a new address is discovered on your network, whereas Uptime Kuma can only track the known services that you have configured. And watch my Pi-hole tutorials playlist to learn about how to leverage the Pi-hole local DNS capability and other goodies as well. And we learned how to use NetAlert X to back up your home lab network address assignments. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.